Have you ever wondered why distance and displacement sound alike but don't mean the same thing? Let's break it down easily. Welcome back to Easy Physics with Omonye, where we make physics simple and fun. So today we will be looking at distance and displacement. Before we dive into today's lesson, let us quickly look at what we did from the previous lesson. From the previous lesson, we differentiated clearly between scalars or scalar quantities and vector or vector quantities. We said scalars are those physical quantities which possess only magnitude, whereas vectors are those physical quantities which possess both magnitude and direction. Moving to today's lesson, distance and displacement. In physics, distance and displacement are used to indicate the length between 2 points. However, these two are not one and the same thing. The concept of distance. Distance can be defined as a physical measurement of length between 2 points. So, when we measure something physically between one point to the other point, we call this what? Distance. It does not take into consideration the direction between the 2 points it measures. Hence, it is a scalar quantity. That means these 2 points, point A, point B, distance does not take note of what direction these 2 points are. As a result, we call it a scalar quantity. Distance is a scalar quantity. That is a physical quantity that possesses only magnitude. This therefore means that distance has only magnitude but no direction. For example, 10 kilometers. The concept of displacement. Displacement is defined as the distance traveled or moved in a specified direction. Displacement takes into consideration the direction between the different points it seeks to measure. Hence, displacement is a vector quantity. So now, in the case of displacement, is the distance traveled or moved in a specified direction. Unlike distance, distance does not take note of the direction, but in the case of displacement, it takes note of the direction, which makes it a vector quantity. That is a physical quantity that possesses both direction and magnitude, both magnitude and direction. Thus, it has both magnitude and direction. For example, 10 kilometers due east. The 10 kilometers is the magnitude or value, while due east is the direction. So both distance and displacement have the same SI unit, which is meter. They could be expressed in kilometers, miles, and so on. We can see clearly that we have a table to differentiate clearly between distance and displacement. Distance is a scalar quantity, whereas displacement is a vector quantity. Number 2, distance, it is the length covered along the path of movement, whereas displacement, it is the distance measured along a specified direction of movement. So if asked to differentiate clearly between distance and displacement in a tabular form, this is a very good tabular representation, and we can take note of these clear differences. Remember, if you found this lesson helpful, please like, subscribe, and turn on notifications so you don't miss the next topic, which is going to be on measuring instruments, part 1. Thanks for watching. This is Omonye, making physics easy, one lesson at a time.